Good evening. Yesterday, there was a request from some students to work some more problems on childhood. So today I'll be working at least other 10 or 15 problems on childhood. So, more problems on childhood. So I have chosen all categories of problems. It may be involving one variable, two variable, all types are combined here so that it will be a sort of revision. First problem, y is equal to e to the power of 5 sine inverse x. See, normally what we do? We take y as e to the power of u is 5 sine inverse x. That's the actual method. But yesterday I have taught you how to work directly. So you can write dy by dx equals. You must remember when y is e power x, dy by dx is also e power x. No change. So here you take this as u. So if it is e power u, it is same as e power u. So I am going to write that as it is 5 sine inverse x. Or the first obstacle is e. So I'll differentiate e power. Now I should differentiate 5 sine inverse x. It is something like 5 in k into u. So 5 is a constant and sine inverse x is into 1 minus x square. Repeat, first you should differentiate e power u, that is e power u only, whatever is there, you write that. After that, you have got to differentiate 5 sine inverse x. 5 is a constant, root of 1 minus x square. There is a possibility some students may get confusion because I told you yesterday, supposing you have got sine cube x, which is the first obstacle here, power. So, or let me work the problem itself here. Let me take that itself as an example so that you will have a clear idea in what way these two problems are different. And take the same example. Here we don't take this as power. E power, the entire thing is a function. Whereas here, this is nothing but sine x whole cube. So something like x cube or u cube. So when you differentiate, u cube will become 3u square. So 3, what is in place of u sine square x. Now we have differentiate, power is differentiated, then you have differentiate sine x is cos x. So these two differences should make out here. 5 e power 5 sine inverse x. 5 sine inverse x is not a power. Okay, let's go to the next problem. Y is equal to log of root sine x. So when you differentiate this, first log is there. So the difference of log is 1 over. So 1 over whatever is there, you write it. Now the next, you got root, differentiate root x, 1 over 2 root x. So 1 over 2 root sine x. Then if you differentiate sine x, that is cos x. If you simplify this, we get cos x over 2 sine x. So first you are differentiating log. Log is 1 over root. Whatever is there you are going to write. So you can, in mind you can keep this as log u. Log u is 1 over u. Then it is not just u, it is root u. So first you should differentiate root. Root x is 1 over 2 root x, so I write 1 over 2 root sin x. Then I enter inside and differentiate cos x. As I was explaining yesterday, you got to go step by step, opening the first obstacle, then next like that. But this problem can also be worked by another method. What is another method? The given problem is log of sin x to the power of half. Log of sin x to the power, you can write like that. But you know there is a formula, you studied in first year PUC, log m power n is n log m. So remember, whenever you are working a problem of logarithm, see whether you can use the laws of logarithm. That will simplify the work. So you can write this as y is equal to half log sin x. This m power n is log n log m. So what will happen now? Now you differentiate this. dy by dx. Sorry, this should not be clear. This I have to keep this as it is. This is the half log sin x after simplification by x equals half is a constant. So keep the constant as it is. Log of anything is 1 over something. Therefore it is 1 over sin x. Then sin x differentiation is cos x. Getting cos x over 2 sin x. You can see both the answers, they are one and the same. So whenever logarithm is there, if you use the logarithmic laws, the working becomes simpler. This is an example. Let's go to the next problem. So today, mostly I will be working more problems than chain rule, because I also believe if you are good in chain rule, rest of the calculus becomes easy for you, because almost all the concepts are explained here. The next problem, y is equal to cosecant inverse of 2 log x by 3. When you look at the problem, you feel it is complicated because cosecant inverse is there, some 2 log x by 3 is there. No. Follow a systematic method. What is the first thing? You should differentiate cosecant inverse x. So you have to refer to the table. What is the derivative of cosecant inverse x? dy by dx equals minus 1 over x into root of x square minus 1. So here dy by dx is equal to minus 1 over, in place of x you have got this, so write that 2 by 3 log x into root of 2 by 3 log x whole square minus 1. You have just differentiated cosecant inverse x. Now you need to differentiate 2 log x by 3. So keep 2 by 3 constant. Log x is 1 by x. Because if you try to simplify, you can cancel 2 by 3. Cannot go for any simplification because they have not given prove that. So whenever a problem is given prove that, then only we'll go for simplification. Let's go to the next problem. This is the fourth one. Today I'm just writing numbers so that we'll have an idea how many problems work today. Y is equal to cos inverse of 2 e power x minus. Same procedure. Here at cosecant inverse, here you have got cos inverse. Recall when y is equal to cos inverse x. What is dy by dx? It is minus 1 over root of 1 minus x square. So differentiate this dy by dx is equal to minus 1 over root of 1 minus what is x square? 2 e power x minus 3 whole square. So a complete differential cos inverse that enter inside. 2 is a constant, e power x will not change, and differentiation of 3 is 0. The full answer is this. Let's go to the next problem. I'm just writing marking problem numbers only for today. Sixth one, y is equal to sine of m sine inverse root x. So when you look at the problem, don't worry about whether it involves u and v and all. We are following the procedure, tackling the first term first. So here, now dy by dx will be, sine will be, difference of sine is going to be cos. So differentiate sine first. M sine inverse, whatever is there to write. After comparing, we enter inside, m is a constant, leave it like that. Now sine inverse root x, you have got to differentiate. You know what is sine inverse x? Y is equal to sine inverse x. Dy by dx is equal to 1 over root of 1 minus x square. In place of x, you have got root x. Therefore, this is 1 over root of 1 minus x. Because root x whole square is x. Afterwards, the problem is not over. So differentiate root x 1 over 2. Normally, this problem is asked for 2 marks. Any student may stop here. You can continue, you have to continue. Supposing they had given x, then also you can differentiate x and write 1. See, if they have the habit of continuing differentiation and working every problem with chain rule, will never go wrong. Repeat what I said. Now, first you differentiate sine, you get cos. Enter inside, m is a constant, I keep the constant as it is. Differentiate sine inverse. I'm not looking at root x, I'm just looking at sine inverse. Sine inverse x is root of 1 minus x square. But you have got root x whole square is x. Then differentiate root x 1 over root x. Let's go to the next problem. 7th problem. Y is equal to sine to the power of 4 to 5x cube. Sine to the power of 4 into 5x cube. So what we should do? This is u to the power of 4. The power you have to first differentiate. So dy by dx is equal to 4u cube. 4, what is there? You write sine cube 5x cube. They are differentiated power only. Afterwards, we should differentiate sine. Sine is cos 5x cube. So we are differentiate power. Then sine, now enter inside, 5 is a constant, x cube is 3x square, therefore it is 15x square. Repeat once again, first we should differentiate power, it is something like x to the power of 4, that is 4x cube, so 4 sine cube of that, whatever is there, right? Then you differentiate sine, sine is cos, whatever is there, right? Then you differentiate 5x cube, 5 is a constant. X cube is 3x square, totally is 15x square. Let's go to the next problem. 8th one. Y is equal to log of x plus root of x square plus a square. Yesterday also I got a similar problem. I'm just repeating it to see that the concept is more clear for you. Now, dy by dx. First, you should differentiate. Whenever they give prove that, you need to simplify. That you need to remember. Whenever a problem is given as prove that, don't stop after differentiation. You need to complete the problem and arrive at the answer given. As I told you earlier, for some of the students, simplification may be difficult. No matter, you can always differentiate and leave it. At least you will get at least 1 mark for that. This is what I am suggesting for the people in the border cases. We get about 18 marks in the, about 18 marks out of 20 they may get in the assignment. So they should make up another 20-25 marks minimum. I'm talking about the people who have got fear of completing the paper. So all questions of differentiation, whether you follow it or not, first step you can always write, provided you are thorough with the list of formulas are given in the rules. Now it is first log, you have got differentiate log. So what's the difference of log? It is 1 over something. So 1 over whatever is given, you write x plus root of x square plus a square. First we differentiate log, then we enter inside. There are two terms. Therefore, we have got to use addition. So addition rule is differentiate each term. First, I should differentiate x. I get 1. The plus sign and 8. Now I cannot differentiate x square plus a square because there is a root inside. Root sign is there. So first I should differentiate root. It is 1 over 2 root x square plus a square. X square plus a square into, now I should differentiate x square plus a square. X square is 2x and a square is 0. You need to simplify this. We'll come over here. Dy by dx equals 1 over. With this, differentiation is over. As I told you earlier, those who have got problem simplification, don't worry about it. Just differentiate. And see that you don't lose 1 year because you have got a very little time. What best you could do, complete this. Those situations is because of what mistake you might have done in the beginning of the year. Somehow join a good course, and next year don't do that mistake. Right from the beginning, be a little more sincere and certainly save 1 year. Otherwise, that fear you might lose 1 year. I'm just talking to the border case people. So this much anybody can do. Log is this. 1 is x is 1. Root is there. 1 over 2 root. Then enter inside, x square is 2x, a square is 0. Next part is simplification. X plus root of x square plus a square, you are writing as it is. Now we should take the LCM here. The LCM is root of x square plus a square. You get root of x square plus a square plus 8. And you take LCM. These two terms will cancel. You get the answer that you are supposed to get. You get the answer because it was given that product. So this is how we are going to complete the problem. Let's go to the next problem. I think it's 10 or something like that. 10. I'll take a very simple problem first. If y is equal to log of 1 minus cos x over 1 plus cos x. If y is equal to log, I am clubbing all the problems. Some problems where you have got to simplify. How do you know that? You have given us to that. Some problems there is no need of simplifying it. And differentiate and leave it like that. So I'll be combining all the problems so that you get all types of problems in one class. And if you can repeat this problem again at home, as I told you, the previous classes, write all the problems in a separate sheet of paper and work them again. If you don't have any other book, if you have got some other books, you can solve some more problems. If that is not possible, maybe you'll be working on 20-25 problems today. around that. All those problems are written in a separate sheet of paper. Work it out without reference notes. If you can do that, you are thorough with chain rule. Once you are good in chain rule, the rest of the differentiation becomes very easy for you. So let me work this. First, we should differentiate log. So 1 over. But I told you yesterday, whenever log is given, see whether you can use any formula. We can use the formula yesterday also, I was not a problem. Log m by n is equal to log m minus log n. The advantage of using the formula is simplification becomes differentiation itself rather becomes easy. If I don't use log formula, first you are going to write 1 over this, then you are going to use quotient rule. Whereas if you use the formula, you can avoid the quotient rule. So write this as y is equal to log of 1 minus cos x minus log of 1 plus cos. And using the formula, log m by n is log m plus log n. That formula reduces our work. See here, what do we get? dy by dx is equal to 1 over 1 minus cos x. Because I need to differentiate log first, then I should differentiate 1, that is 0. I should differentiate minus cos x. Cos x is minus sin x. So minus cos x is plus sin x. And repeat, differential derivative or differentiation of 1 is 0. Cos x is minus sin x. Minus cos x is plus sin x. Minus is minus sign. Again, same procedure. Log is 1 over. So first I differentiate log and the center inside. 1 is 0. Cos x is minus sin x. So this is minus sin x. Could have left it here. That is not possible because they have to prove that. Again, what is required? You should be good in algebra. First step you can do is there is sin x common, take out that sin x. You get 1 over 1 minus cos x plus y plus sin minus and minus plus 1 over 1 plus cos x. Because both terms are got sin x, I have kept sin x outside. Why do I get a plus sign? I got a minus sign here. So this is equal to, take LCM. What's the LCM? 1 minus cos x into 1 plus cos x is the LCM. Now, here 1 minus cos, therefore you get 1 plus cos x here, and you get 1 minus cos x here. Cos x and cos x cancels. So I think prove that I have not written it. Let me write what is meant as prove that. Prove that dy by dx is equal to cosecant x. Very simple answer. Now what do we got? How much? I mean, how far we have come? If you simplify this, this is 2 cosecant x. Answer gives 2 cosecant. So this cos x and cos x cancels. 2 sin x over 1 minus cos x and 1 plus cos x is 1 minus cos square x. The formula is a plus b into a minus b. But you know that 1 minus cos square x is sin square x. 1 minus cos square x sin square x. 1 sin x you cancel, you get the answer. I'll explain the problem once again because the moment the problem runs into 4 or 5 steps, or half a page rather, psychologically we feel it is difficult. No, it's not so. Because every problem you are working one step at a time. When you are climbing down, from the first floor. You must concentrate on the first step that is there. Every step you have to be cautious. You're not looking at the third step. You're not looking at the end, the step where you are going to complete the coming down. So you are concentrating on the first. Supposing you don't concentrate on the step that you are supposed to get down, definitely you are going to fall. Same procedure in mathematics also. We are not worried about other steps. We are just concentrating on what is in front of us. Our life is also like that. We are not worried about what happens tomorrow. So to take care of today properly, my tomorrow is going to be definitely better than today. So the most important thing is to be cautious and concentrate on what is in hand. So this is a problem given to you. Now I've already explained this the formula. Log n by n is log n minus log n. A differentiate log, I get 1 over minus cos x, 1 minus cos x. Then only I have differentiate 1 minus cos x. 1 is 0, cos x minus sin x. Because I got minus cos x, it becomes plus sin x. Same thing here, only difference is there are minus sin x. Afterwards, we take the LCM. Cos x and cos x get cancels. I get 2 sin x over 1 minus cos square x using the formula. And I should also know that 1 minus cos square x is sin square x, I get answer. This is what I was trying to tell you. Supposing you are not able to come up to this, at least you can, this anybody can write. This step also you can write. Sometimes we get 50% mark for that. And especially for the students who are somewhere in the border cases, the teachers are more considerate. You may not believe. When we used to work the problem, we want to promote the students who are in the border case. But they would not have written anything in the paper. Blank paper, what is that we can do? So we search for somewhere some point is correct. Somebody was giving a simple comment. In one of the examination, a question was asked. The question was, who brought India independence? That was the question. Who brought India independence? The student has written the answer, Pooja Gandhi. The question was, who brought India independence? And the answer was Pooja Gandhi. Perhaps you might have seen the film. But he got 1 mark because Gandhi is correct. That's how our evaluation takes place. We'll especially see, even the government also wants to get very good results. And we concentrate more on these types of children to see that they are promoted. But what is the normal comment we get from the students? Those who fail in the examination, fail 1 to 2. Fail 1 to 2. Please take it. Every teacher, whenever they see, you get an impression about the paper in 5 minutes. Once we take the paper and start evaluating it, about 5 minutes we get an idea. It's a very good paper or a very bad paper. If it is a very good paper, we will try to see where we can reduce the marks. That's a normal tendency. Because whatever marks the student should get should be perfect. She should not get even 1 mark extra. Because the higher level competition is too much. Difference of 1 mark might create a difference of 1000 rank in CET. So the paper has to be perfectly valued for those who are above 90. And those who are below 30, 25, we search where we can give the marks. So some of you, I'm just talking to those people, I repeat this. So at least if you cannot complete the problem, be good in differentiation, every problem, even if it's a problem of second derivative, if it's a problem of application of that, whatever it is. First step, anybody can. Anybody can write. When I'll stress upon these points when I take the actual examination papers. Okay. We'll continue. Some more problems I just want to solve so that you become thorough with the chain rule. 11th problem. Y is equal to y is equal to sine of root 3 into sin x plus cos x. And root 3 is given just to confuse you. Should notice that root is only for 3, not for sin x. Because if it is root is for sin x also, then you have to follow a different rule. When root 3 into sin x is there, ku, the rule ku is enough. If it is root 3 sin x, sin x is also inside, you need to use the chain rule. So you have to be very cautious. And these problems carry 2 marks in the examination. So first step is dy by dx is equal to sine differentiation is cos. You write whatever is there as it is. Root 3 sin x plus cos x. At first differentiate sine becomes cos. Now I have to enter inside. Root 3 is a constant. I keep it as it is. Sin x is cos x plus cos x is minus sin x. And leave it like that, no need of simplifying it. Take the next problem. Y is equal to root of tan of x square plus 3 by 4. All these things are given just to confuse you. You should not get confused. You will not get confused if your basics are very strong. The 2 basics are formula, that is what we call them as tools, and the rules. Now here, dy by dx equals, the first thing that we are saying is root. So first I should differentiate root. It is 1 over 2 root tan of x square plus 3 by 4. I am differentiating root, therefore I write just as it is. Enter inside. You should differentiate tan. Tan of anything is secant square. Whatever is there, you write x square plus 3 by 4 into. Now you should differentiate. So you can read 1 by 4 as it is. I have told you, constant will never trouble you. Don't trouble the constant. 1 by 4 is the constant. It is in 4 is the denominator. Leave it like that. Now I should differentiate x square. That is 2x. I must differentiate 3. 3 is a constant. And here this constant is not 0 because I am using ku. So I am keeping the constant outside. We not simplify. Can leave it like that. Let's go to the next problem. Y is equal to 3x cube minus 4x square plus 5x plus 7 to the power of 4. Now, we have to find dy by dx. Here it's the power. So first we should tackle the power. Something like u cube or x cube. And not u cube, x to the power of 4 or u to the power of 4. It is 4u cube. 4 into it as it is. 3x cube minus 4x square plus 5x plus 7 to the power of 3. I am recalling and using the formula. If dy by dx is x to the power of 4, sorry, y is x to the power of 4, then dy by dx is 4x to the power of 4 minus 1, nx to the power of n minus 1, that is 4x. After that, I should enter inside and differentiate the terms inside the bracket. Power is over, now I should differentiate 3x cube. 3 is a constant, x cube is 3x square, therefore it is 9x square. 4 is a minus 4 is a constant, x square is 2x, therefore minus 8x. 5 is a constant, x is 1, and differentiation of 7 is 0. Let's go to the next problem. 14th problem. y is equal to, I've taken all types of problems, tan root x. This is because of the request from a student to work more problems chain rule. And I am very sure by working more problems in chain rule, you will gain better knowledge and you have got to work once again. Okay? dy by dx is equal to, first obstacle is secant, so you should differentiate secant. So recall, if y is secant x, dy by dx is secant x tan x. So this is secant, I am not writing x but I am writing whatever is there. Secant tan root x into tan x. So we have differentiated secant first. Now I want to differentiate tan. Tan differentiates secant square. You have got root x, write it as it is. Then you should differentiate root x, that is 1 over root x. You will let us simplify it. 15th problem. Y is equal to 2 into root of cot x to the power of 2 by 3. Cot x to the power of 2 by 3. Whatever this problem. So 2 is a constant. So keep 2 as it is. dy by dx is equal to keep 2 as it is. Now I should differentiate 2. So what is the first thing is you have to differentiate root first. So it is 1 over 2 root cot x to the power of 2 by 3. See, this power 2 by 3 is given just to confuse you. You are just concentrating on root 1 over 2, root whatever is there you write. Next you have got differentiate cot. What is the difference of cot x? You can refer to the notes and see. If y is cot x, dy by dx is minus cosecant square x. So I should write here minus cosecant square, not writing x but I am writing x to the power of 2 by 3. This is what is given I should. It's not over. I should differentiate x to the power of 2 by 3. That is 2 by 3 x to the power of 2 by 3 minus 1. I can leave it like that or I can just write 2 by 3 minus 1 as minus 1 by 3. Or you can leave it like that because I have not asked you to simplify. You can leave it like that. One more problem. I'm just among the problems I'm just repeating it so that you can recall the method. Log of a minus x, log of a minus x over a plus x. Prove that dy by dx is equal to minus 2 over a square minus x square minus 2a over. The moment you notice, prove that, so you need to simplify. We already worked on problem of log of 1 minus cos x over 1 plus cos x. Do you what is the formula that we use? Log m by n. Use the same formula. Y is equal to log of a minus x, log m minus log n, minus log of a plus x. dy by dx. First, you should differentiate log. It is 1 over a minus x. That is, I should differentiate a minus x. A is a constant, therefore it is 0. X is 1, but there is minus x, therefore minus 1. Very careful. A is 0, x is 1, but not just 1. Minus x, minus x. Let's go to the next one. 1 over log is a plus x. A is 0, x is 1. Now we should take the LCM. This is minus 1 over a minus x. This is also minus 1 over a plus x. You can keep the minus sign outside and take the LCM. A minus x into a plus x. That is a plus x plus a minus x. X and x cancels. You get minus 2a. And what is the formula? A plus into a minus a square minus b square. Therefore, it is a square minus a. Let's go to the next problem. 17th one. Y is equal to log of root secant x. I think you are noticing here, I have clubbed a problem of different types. One problem where you have got to prove that, another problem where there is no way of proving it. One problem where it has got more steps to be written. The other one, all depends. Now here, why I have given this here is to remind you that normally what we do is first we'll differentiate log, then root. That is not required. Whenever log is there, just spend 1 more minute extra. It's very important. The moment you see a problem with beginning with log, don't jump to differentiation. See whether you can use any formula. What is the problem given? It is log of secant x to the power of half. By using a formula, the simplification becomes easy. I have explained you already, but I am repeating it. Log m power n is n log n. So this is going to be half log secant x. Half log secant x. Now let us differentiate this. Half is a constant. Log is 1 over secant x. Secant x is secant x tan x. Half is a constant, keep it as it is. Log is 1 over secant x. And secant x is secant x tan x. Now we can cancel secant x. So you get half tan x. They have not given prove that, but I have proved it because simplification is not that difficult. Let's go to the next problem. 18.1. Y is equal to tan inverse of 2 plus x over 3 plus x. Prove that dy by dx equals 1 over 2x square plus 4x, sorry, 2x square plus 10x plus 13. 2x square plus 10x plus 13. So the first thing you have to differentiate is tan inverse. We call if y is tan inverse x and dy by dx is 1 over 1 plus x square. So what is the first step here? Dy by dx is equal to 1 over 1 plus 2 plus x over 3 plus x whole square. So you have to differentiate tan. The problem is not over. You should differentiate this. You should notice it's a quotient rule. A problem involving chain rule as well as quotient rule. Follow the same procedure. What is quotient rule? You have to recall. If y is equal to u by v, dy by dx is v into du by dx minus u into dv by dx divided by v square. First, you should differentiate numerator, keeping denominator as it is, then put a minus sign. keep the numerator as it is, differentiate denominator divided by d. This is the formula. So I should keep the denominator as it is, I should keep 3 plus x as it is. I must differentiate numerator. 2 is 0, x is 1. 2 is 0, x is 1. There's a minus sign. I write a minus sign. First we should the bracket. Now I should keep the numerator as it is. That is 2 plus x as it is. I must differentiate 3 plus x. 3 is 0, x is 1. Divided by v square. That is 3 plus x whole square. So this completes differentiation. Next is your high school knowledge, how good you are in simplification. So this is nothing but 3 plus x whole square plus 3 plus x whole square plus 2 plus x whole square. I'll explain what I have done. A by b whole square is a square by b square. I have written it orally. Take an LCM. This denominator LCM will go to numerator. Now this is 3 plus x whole square, that is 2 plus x whole square. And you have got to simplify the other term also. Into the denominator is 3 plus x whole square. This is 3 plus x minus 2 minus x. 3 plus x minus 2 minus x, x and x will cancel. You notice that 3 plus x whole square also cancels. And you get 3 minus 2 is 1, so we got 1. Numerator we got, use a plus b whole square formula, a square plus 2ab plus b square. Here also a plus b whole square formula, a square plus 2ab plus b square. Simplify this, x square plus x square is 2x square. 6x plus 4x is 10x. 9 plus 4 is 12. Just repeat what we have done. First we differentiate tan inverse over 1 plus u square. Then it's a quotient. So we have this problem can be asked in the examination for 4 marks or 3 marks. Suppose you are not able to complete the problem, at least this much you can always write. This is what I am emphasizing. Differentiation part, they should not be difficult. So what you can do is, suppose you are not able to complete it, leave some space for that, go to the next problem, then you can come back to it. Okay, let's go to the next problem. Y is equal to x cube into cos cube 2x. I have chosen this problem because if you understand this clearly, then it means you have no problem with the chain rule. Because everything is involved here. When you look at this, there are 2 terms, 2 functions. This algebraic, that is trigonometric. Therefore, you need to use quotient rule. Sorry, product rule first. What is product rule? I have called it as excuse me rule. You have to keep one of them excuse, the other one you should differentiate. So what we can do is, we will ask excuse for cos cube 2x and differentiate x cube, that is 3x. I'm using product rule because it's the product of 2 functions. Plus, don't I write the problem again, formula again. dy by dx is, if y is uv, v into du by dx plus u into dt by dx. That's all. So here, v is x cos cube 2x, I have written as it is. Du by dx is, I have differentiated x cube, that is 3x square. Plus, I should keep x cube as it is. And I should differentiate cos cube 2x. That itself is a different problem. So the first thing you should realize, the power you should differentiate. So this is 3 cos square 2x. So I have just differentiated power. Now I should differentiate cos. It is minus sine 2x. Now I should differentiate that 2. I get multiplied by 2. 2x is 2. You need not simplify this again. You just leave it like that because they have just asked you to. And it can't be simplified also very clearly because it's a combination of two functions. Let's go to the next similar problem. Y is equal to cos x cube. Here the problem was cos cube x. This is cos x cube multiplied by sine square x to the power of 5. Let me spend some time on these two problems. This was the product rule, this was the product rule. Whereas here, x cube differentiation was easy, chain rule was not required. Whereas cos cube 2x, we need to use chain rule. But what about this problem? This also chain rule, that's also chain rule. But the method is same. It's a product rule problem. So let us keep one of them as it is. I'll keep sine square x to the power of 5 as it is and differentiate cos. First cos is sine x cubed into x square is 3x. Repeat. Excuse for this sine square x to the power of 5. Differentiate. There is a lot of difference between this is cos cube. Therefore, we differentiated cube first. This power is not for cos, it's only for x cube. So cos is free. So let us differentiate cos, you get sin x cube, then differentiate x cube, you get 3x squared. Plus, now you should ask excuse for cos x cube. Differentiate. Now this is the power is first. Therefore, it is 2 sin x to the power of 5. Then sine is cos x to the power of 5. And 5 is 5, x to the power of 5 is 5x to the power of 4. You need not simplify this. Let's go to the next problem. Y is equal to tan cube 5x square. This was a product rule problem because there are two terms. This is not a product rule, only chain rule problem. First, what should you differentiate? You should differentiate the power. So, u cube is 3u square. 3 tan square and 5x square as it is. Then you should differentiate tan. Tan is secant square 5x square. Then you should differentiate 5x square, 5 is a constant, x square is 2x and x. First power, 3 tan, then 5x square. Let's go to the next problem. Y is equal to sine of cos x cube. So again, it is not a product rule problem. It's only chain rule. So first differentiate sine. You get cos of cos x cube. And just enter inside your differentiate cos. Cos is minus sine x cube. Then you should differentiate x cube. Next problem. y is equal to sine of root of sin x plus cos x. Normally you get these types of problems for 2 marks in the examination. So first you should differentiate sine. It is cos, whatever is there to write. Sin x plus cos x. When you enter inside, root is there for both. Therefore, we should first differentiate root. It is 1 over 2 root sin x plus cos x. Sin x plus cos x. Enter inside. Sin x is cos x. Cos x is minus sin x. No need of simplifying it. So first sine you should differentiate, then root, then what is inside the root. Next problem. Y is equal to 1 over x square minus 5x plus 7 to the power of 4. So when you look at this problem, you think that you are going to use quotient rule. It is not necessary because numerator is not a function. So you have to recall this. 1 over e to the power of m can be written as e to the power of minus m. So bring this to numerator. So write this as x square minus 5x plus 7 to the power of minus 4. Because numerator is just a constant. Now, dy by dx equals, you have to recall this, y is equal to x to the power of n. Dy by dx is n x to the power of n minus 1, where n can be positive, negative or fraction. So this is negative, n is minus 4, x is nothing but x square minus 5x plus 7 to the power of n minus 1. N is minus 4 minus 1. The problem is not good. You have to simplify this, rather differentiate this. 2x minus. You can leave it like this, or you can write this as power 5. Minus 5 there. Minus 4 and minus 1 is minus 1. Next problem. Y is equal to cos inverse of root x. Compared to earlier problems, this should be easy for you. So what is the first step you should write? What is cos inverse x? Minus 1 over root of 1 minus x square. Therefore, minus 1 over root of 1 minus x. Because x square, it is root x whole square. Then you have to differentiate root x, it is 1 over 2. So with this, I will conclude chain rule and we will continue the implicit function problems we were working yesterday. As per the student request, I just thought, let me work more problems. I think that will suffice. There are quite a number of problems. So let us continue the implicit differentiation that we had stopped yesterday. What is the only extra thing you should remember? If you have got x square, when you differentiate you get 2x. If you have got y square, you get 2y dy by dx. Just repeating it. If you have got sin x, on differentiation you get cos x. If you have got sin y, on differentiation you get cos y dy by dx. My dy by dx because we are differentiating with respect to x. So let us continue the implicit differentiation. I think the problems that I worked today, if you can work them again, definitely you can be master childhood. Once you are thorough with childhood, absolutely You feel more confident? Okay, take the problem. I just want to repeat what we did yesterday. 5x square plus 4xy plus y square is equal to 4. So yesterday I taught you this, but I am just working a similar problem again to help you to recall. So the moment you say this, it's an implicit function. What is an implicit function? Let me repeat, I told you yesterday. Any function which has got more than one y term or there's a power on y is called an implicit function. Therefore now, it's an implicit function, we have to differentiate term by term. First I should differentiate 5x square. 5 is a constant, x square is 2x, therefore it's 10x. Plus 4 is a constant. You must realize xy is a product. Therefore, excuse the rule, excuse for y, differentiate x, that is 1. Excuse me for x, differentiate y, you get dy by dx. So we have to go term by term. This is direct, this is product rule. Now differentiate y square, it is 2y dy by dx. That is equal to 0 because 4 is a constant. So let me just simplify this. 10x plus 4y plus x dy by dx plus 2y dy by dx. Yesterday at the end of the class, I thought a direct method of writing dy by dx. What is that method? Repeat this. So now this term is, I told you whenever it is multiplied by dy by dx, it should go to denominator, not multiply numerator. Minus 10x, so it should plus, keep minus sign outside, plus 4y over, this is multiplying x plus 2. Yes, excuse me for a minute, I attend an important call. One minute, I'll just get back. Phone ಮಾಡಿದ್ರಿ? ಶಿಲ್ಪ ವಾಣಿಜ್ಯ ಕಾಲೇಜಿದೆ ತೊಂದರೆ ತಂದ್ಬಿಡು ಎಲ್ಲ ನಿಲ್ಸೋಣ ಇಲ್ಲ ನಡೆದಿಲ್ಲ ನೀನು ಸ್ವಲ್ಪ ಕಾರ್ಯ ಮಾಡಿದ್ರೆ ನಿಲ್ಸಿ ನೋಡೋಣ ಸುರೇಶ್ ಕಾರ್ಯ ಮಾಡಿ ನಿಲ್ಸೋಣ ಸುರೇಶ್ ಮಾಡಿ ನಿಲ್ಸಿ. Sorry, I got an important phone call. So let me continue. So direct writing is write a minus sign and put a bracket. The time is not multiplied by dy by dx, it goes to numerator. So this will go to numerator. This will also go to numerator because it is not multiplied. The term is multiplied by dy by dx, it goes to denominator. Now you can arrange and see this is a direct way of getting this. So let me go to the next problem. 4x square plus 5x square y minus 6x cube plus 3xy square plus 7 I've taken a little lengthy problem. The main reason being to make the concept clear. So it's to differentiate 4x squared, I get 8x. Now 5 is a constant, keep it outside, and x square y is a product. That you should realize. So what is the method for product? Excuse me for y, differentiate x square, you get 2x. Excuse me for x square, differentiate y, it is 1 into dy by dx or dy by dx. Then minus sign is there, minus 18x square, then plus 3 is a constant, keep it outside, y square you keep it as it is, x is 1, then you keep x as it is, differentiate y square, that is 2y dy by dx. I'll repeat, first differentiate 4x square, 4 is a constant, x square is 2x. You notice that it's a product and 5 is a constant, keep 5 outside, excuse me rule. Keep y, differentiate x square, keep x square, differentiate y. This is direct, 6 is a constant, x cube is 3x square, differentiate x square. Again, a product, keep 3 outside, keep y square as it is, differentiate x, I get 1. Keep x as it is, differentiate y square, I get 2y by dy by dx, that is equal to 0. Now let us simplify this. 8x plus 10xy plus 5x square dy by dx minus 18x square plus 3y square plus 6xy dy by dx. I'm just multiplying, that's all. 8x, 10xy, 5x square, minus 18x square, 3 into y square, 3y square, 2 into 3 is 6, 6xy. What's the procedure method I have taught you? Write a line, put a minus a and plot it. Not multiplied goes to numerator. Not multiplied by dy by dx. So this also goes to numerator. This is multiplied, it goes to denominator. This is not multiplied, numerator. This is not multiplied, numerator. This is not multiplied. It is not equal distribution. Whichever term is multiplied by dy by dx, it goes to denominator. Not multiplied, it will go to numerator. If you have any difficulty, you can just do the other method, grouping all the terms containing dy by dx, shifting the other term, you get the same answer. By this method, you are avoiding one step. So let's go to the next problem. Sin square x plus cos square y is equal to 1. Sin square x plus cos square y x is equal to 1. So sin square x, first you should differentiate. You know pretty well sin square x cannot be differentiated directly, you need to use chain rule. First you should differentiate power. So this is 2 sin x. Then you should differentiate sin x, that is cos x. Here also you should differentiate power. So plus 2 cos y. Then you should differentiate cos, it is minus sin y. You should differentiate y dy by dx. Here we should have differentiate x also, but it is 1. I have not written it. So power is first 2 sin x is cos x. Power is 2 cos y. Cos y is minus sin y, and 1 is dy by dx. We get dy by dx because difference in y is dy by dx. Now we have to find dy by dx. What is the method? Dy by dx, this will go to that side. Minus 2 sin x cos x divided by minus 2 sin y cos y. Can leave it like this, or minus and minus will cancel, you get a plus sign only. And you know that 2 sin x cos x is sin 2x, and 2 sin y cos y is sin 2y. So you can simply find different. Otherwise, you can leave it like that. Let's go to the next problem. Sin square y plus cos square xy is equal to 5. Where it was sin square x plus cos square y, here cos square xy is given. The moment you see xy, syndication, you have got to use chain rule. So sin square y is same thing as sin square x. Here it is 2 sin x cos x. Here it is 2 sin y cos y. You need not stop there. You have got to differentiate y also. dy by dx. Remember, whenever you are differentiating y term, you have to multiply by dy by dx. Now, this first you should differentiate power. That is 2 cos xy. Then I should differentiate cos, that is minus sin xy. Then I should differentiate x, y into 1 plus x into dy by dx. I repeat, sin square y is 2 sin y cos y into dy by dx. First you should differentiate power 2 cos xy. Then you should differentiate cos, it is minus sin xy. Then you should differentiate xy. Xy is product rule. Keep y, differentiate x. Keep x and differentiate y. Now we are going to simplify. This is, if you want, you can write 2 sin y cos y as sin 2y. dy by dx. Plus, you need to multiply here. So this is 2 sin xy cos xy is minus sign is there, you set the minus sign outside. Sin 2xy. 2 sin a cos a is sin 2a. Instead of x, you have got xy. So you can write this as 2 sin xy into y. That is minus y 2 sin xy. You have to multiply this term also. Minus, this is plus x sin 2xy into dy by dx. That is equal to. I am writing 2 sin y cos y sin 2y. 2 sin xy cos xy sin 2xy. There is a minus sign, written minus sign. This term has multiplied with y, I get one term. This term has multiplied with x. Now I should write what is dy by dx. dy by dx equals, I told you, put a minus sign and a bracket. This is multiplied by dy by dx, goes to denominator. This is not multiplied, goes to numerator. This is multiplied, goes to denominator, plus x sin 2x. Let's go to the next problem. See, there are some problems of implicit functions involving trigonometric formulas. There are special problems. Today I just work one of them just to give an idea. The rest of the problems I am going to postpone it. The main reason being, we work all of them together when we solve the examination papers. I call them as special problems. So today I just give an idea about one problem. The problem is given like this. Cos inverse of 1 minus 2x square. Actually, we have to recall the formulas of trigonometry of first year. That I am not doing it here. I have decided to take all those special problems at a time when we solve the question papers. so that you can put them in one sheet of paper, and those problems are must go through on the previous year of the examination. See here, what formula is required, only that I am writing. There is a formula. Cos 2a is cos square a minus sin square a, 2 cos square a minus 1, or 1 minus 2 sin square. Very big formula. Here we have to decide which formula I have to use. So if I put x is equal to sin theta, I can write this 1 minus 2 sin square theta. What is 1 minus 2 sin square theta? It is cos 2 theta. So put x is equal to 2 sin theta. So problem becomes, these are all little difficult problems, but you need to remember the formulas. There are about, one good thing about this chapter is there are about 7 or 8 problems of this type. I've decided to work all of them together when I saw the question papers, so that there will be one sheet of paper. So you can remember those and work it out. Okay? And for those who have got difficulty in formulas, supposing it is not given as proof that, if the problem directly given, I'll teach you how to get 1 mark. I'll come back to that later. Let me complete this. Now, this is 1 minus 2 sin square theta. That is cos inverse of cos 2 theta, that is 2 theta. Because again, the trigonometry formula yesterday I listed. Sin inverse of sin x is px, cos inverse of cos x. So, this is normally these problems for those who are scoring more than 90 or more than 80. For those who have got some basic difficulties, for them I'll teach another method. How to get 1 mark from this. So y is equal to, now what was theta? There's no 2, sorry. Put x equal to just sin theta, not 2 sin theta. Put x equals sin theta. 2 is already here. So x equals sin theta means, then what is theta? Theta equals sin inverse x. So you write this as 2 sin inverse x. Now differentiate. 2 over root of 1 minus x. This is the actual method. These are all the problems little above the standard. Sometimes what happens for the students who are little poor in mathematics, looking at this problem, they get confused. So, but these problems can be avoided. And so, how to get 1 mark from this? I'll just write it here. Y equals cos inverse of 1 minus 2x square. Now you know it's something like cos inverse u. What is cos inverse u? Minus 1 over root of 1 minus x square. 1 minus 2x square whole square. You differentiate cos inverse. Then enter inside. 1 is 0. X square is 2x. Therefore it is minus 4x. You leave it like this. Supposing they are just given differentiate, you will get complete marks. If they are given, prove that at least you will get 1 mark. So these are the areas I will be touching upon when I take up the question papers. There will be around 15 plus marks, which you can always get with minimum preparations. The moment you get more than 15 to 20 marks, you are safe. You are saving 1 year. So let's go to the next problem. So these types of problems I am going to take up later. but I am just concentrating on only some problems. One more of this type. Y is equal to sine inverse of 2x over 1 plus x square. Problems involving trigonometric, inverse trigonometric functions, we call them as. So again, I'm just writing the formula that is required for this. There's a formula. Sine 2 theta is 2 tan theta or 1 plus tan square theta. This formula is required for this. So put x is equal to tan theta. Then y will be equal to sine inverse of 2 tan theta over 1 plus tan square theta. That is sine inverse of sine 2 theta. What is sine inverse of sine x? It is x. Therefore, you get 2 theta. But what is tan theta? Tan theta is x. What is theta? If tan theta is x, theta is tan inverse x. So you can write this as 2 tan inverse x. dy by dx equals 2 over 1 plus x. So if you can remember the formula and work it out, you get the complete marks. Supposing you are not able to recall the formula, don't leave the problem as it is. I'll just teach you how to get 1 mark. The problem is y is equal to sine inverse of, I am repeating this almost all the problem differentiation with little effort. You can always write one step. So 2x over 1 plus x square. You differentiate this. First you should differentiate sine inverse. That is 1 over root of 1 minus x square. 2x over 1 plus x square whole square. Differentiation of sine inverse is 1 over root of 1 minus x square. In place of x you have got this like that. Now you should use quotient rule. That you know, because once you differentiate sine inverse, you are entering inside. It's a quotient rule. So what is quotient rule? Keep numerator as it is. Differentiate. Sorry. Keep denominator as it is. Differentiate numerator minus. Keep numerator as it is. Differentiate. 1 is 0. X square is 2x over 1 plus x square whole square. You need not simplify. Just leave it here. So whenever you have got difficulty in recalling, just for one more of this type, just to explain. Supposing you are not good in trigonometry, you are not able to recall the formula, at least you can get 1 mark. So one more problem taking. Y is equal to cos inverse of 1 minus x square over 1 plus x. Again, this requires a formula. I'm just writing only the formula. Cos 2 theta is equal to 1 minus tan square theta over 1 plus. This is the actual formula I got to use. So, for this problem, put x is equal to tan theta. What do you get? Cos inverse of 1 minus tan square theta over 1 plus tan square theta. Which is nothing but cos 2 theta. Cos inverse of cos 2 theta. That is equal to 2 theta. So y is equal to, what is theta? tan inverse x. So dy by dx equals 2 over 1 plus x square. Supposing you don't remember the formula, still you can get 1 mark. How? So dy by dx equals, this is cos inverse, so 1 over root of 1 minus x square over 1 plus x square whole square. Now you need to use quotient rule for this. Keep the denominator 1 plus x square. 1 is 0, x square is minus 2x. Minus, keep the numerator as it is. Differentiate denominator. You get 2x over 1 plus x square whole square. Leave it like that. If possible, you can simplify because it takes more time. But sometimes they give the answer also. Prove that. dy by dx is equal to 2 over 1 plus x square. I told you when the answer is given, you have got to use trigonometry. But still, sometimes, without knowing the formula also, we can manage. The answer is given. I'll teach you how. Look at the answer. Leave that number. Leave that 2. What is that you have got? 1 over 1 plus x square. Which function on differentiation gives this? Recall. It is tan inverse x. If y is equal to tan inverse x, dy by dx is 1 over 1 plus x square. So, you get a clue. I should get tan inverse x. If you have to get tan inverse x, what should be x? It should be tan theta. Repeat. Even if you don't know the answer, you can manipulate. That's the trick. The answer given is 2 over, leave that 2. Just take, always leave that constant and take that 1 over 1 plus x. This is a derivative of tan inverse x. So you should get tan inverse x here. But if you have to get tan inverse x, what should be x? Tan theta. So blindly put x is equal to tan theta, whether you know the formula or not. So y is equal to cos inverse of 1 minus tan square theta over 1 plus tan square theta. So this is y is equal to cos inverse of, because 2 is there, cos 2 theta. So y is equal to 2 theta, 2 tan inverse x. So dy by dx is 2 over 1 plus x. I'll take the blind method for the other 2 problems also that I worked. So this is one clue for you. If they give the answer, indirectly they are giving a hint. Just one more, I'll repeat the problem that I worked today, so that how you can manipulate the result, even though you don't know the formula properly. You can always do that. It's not for all, it's only for some of you. The answer we got was minus 2 over root of 1 minus x square was the answer we got. So leave, not minus 2, plus 2 we got. So leave that 2. When you leave that 2, what do you get? You get 1 over root of 1 minus x square. Which function on differentiation has given this? If y is equal to sin inverse x, then you get derivative as this. So what's the clue for you? Put x equals sin theta. So when you put x equals sin, blindly working, cos inverse of 1 minus 2 sin square theta, because you have got 2 there, cos inverse of cos 2 theta, that is y equal to 2 theta, that is 2 sin inverse x, therefore it is written 2 over root of 1 minus x square. So if they give the answer, then it will be much simpler. I'll just teach one more problem which you can work without knowing the formula also and close. The other problems I am going to take up once I start solving the question papers, which might take another 2 days because the speed with which we are going, I think we require a little more time. A problem like this is given. Y is equal to tan inverse of 3x minus x cube or 1 minus 3x square. If they are given you, prove that dy by dx is equal to 3 over 1 plus x square. You can follow the same procedure. Leave that 3. 1 over 1 plus x square, differentiation of tan inverse x. So put x is equal to tan theta. A wise examiner will not give proof that. Supposing they are given, indirectly they are giving a proof for you. So you put x is equal to tan theta. Now, blindly I am working. Wherever x is there, I tan theta. 3 tan theta minus tan cube theta over 1 minus 3. It is very simple. I got to include that I have to put x equals tan theta because the derivative tan inverse x is 1 over 1 plus x square, x should be tan theta. Now whether I understand or not, whether I know the formula or not, I can write this as tan 3 theta. Why 3 theta? Because 3 is there. So y is equal to 3 theta. That is 3 tan inverse x. So dy by dx is equal to 3 over 1 plus x square. So I'll emphasize this little more when I solve the question. But I'll give some hint for it. If you know the formula, well and good. If you don't know the formula also, still you can manage looking at the answer. But if you don't know that tan inverse x on differentiation give 1 over plus x square, nobody can help you. That's why I told you the 18 formulas that I have given you, there's the rules that I have given you, you need to remember them. Those should be things must be in your fingertips. Then only you can work the problem and you can be sure of getting at least 50 out of. So with this shall close today's class. Tomorrow I'll take up the next concept that I am going to discuss is logarithmic functions. So all types of problems that we find in this chapter, differentiation, 1 or 2. In case if you feel that the problems that I work are not sufficient, you can always, just like yesterday one student has sent a message to me, please work more problems to improve. I'll take a little more time today. So but I am winding up the implicit function and chain rule. I'll be taking up logarithmic functions tomorrow. Thank you. Good night. Let us meet tomorrow.